Today you guys are going to learn, it's going to say lesson 7.5. It's not. It's because I just used this with my 7th graders last year when I taught this. So this is actually not in our chapter that we're learning, but it fits right in with proportions. Um, so we're going to be learning it now anyways. So we're going to be talking about scale drawings. So a scale drawing is a proportional, two-dimensional drawing of an object. Okay, so it's like kind of like a blueprint for a house is a scale drawing because you can't fit an entire life-size house on a piece of paper. So a scale model then is a proportional three-dimensional model of an object. So it's, for example, if you've ever seen them make like a 3D miniature house to show you what it's going to look like, or a building or something like that. So it's kind of that 3D version. Okay, now a big thing that we need to know here is what scale is. The measurement in scale drawings and models are proportional to the measurements of the actual object. So they use a scale to give the ratio that compares the measurements of the drawing or model to the actual measurements. So for example, they might have 1 inch in the scale model or drawing is actually 10 miles in real life, okay, or 10 feet in real life, or some sort of scale. You might have also seen this like on a map, okay, where 1 centimeter is 50 miles because they can't fit the actual distance on a map, okay. All right. Another important key vocab word that's not on here that's different from scale is scale factor. So make sure you have this on your paper. Okay, the difference between a scale and a scale factor. A scale is talking about how many inches for how many miles. A scale factor is talking about what is the multiplying factor in that scale. Okay, so if I asked you for the scale factor between the model and the actual, our answer here would be that it's going to be 1/10, or sorry, it's not going to be, yeah, it's going to be 1/10 of the size. Okay, or it could be where something is like 3 times the size of something super small and you're making it bigger. Your scale factor could be 3 because it's 3 times the size, or 1/2 of the size. So that's what we're talking about, scale factor. Scale is when we're comparing the measurements. Scale factor is when we're comparing like the actual sizes. What's going to be the size difference of the scale and the actual. Okay, and this maybe will make more sense when we get to an example about it. So here we have what is the actual distance D between Cadillac and Detroit. All right, so what we would do here is we are going to use a centimeter ruler to find the distance on the map between Cadillac and Detroit. So here is where we would have Cadillac. Here is where we would have Detroit. We would take that centimeter ruler and we would measure the straight shot distance right there. And we would use this scale. Now when we set up a proportion, okay, we're going to set it up. And this on your paper is not filled in yet, so make sure you fill this in. Our scale is 1 centimeter to 50 miles. So that's the information we're given. 1 centimeter over 50 miles. And actually, I'm just going to rewrite it bigger down here. Okay, and that's going to be equal to, and then how many centimeters we measure, because if centimeters is on top and the left, it has to be on top and the right. We would measure and we would see that that's 3.5 centimeters. Okay, and we want to know what is that actual distance, D. All right, so to solve, we use those cross products. We take 1 times D, which is equal to 50 times 3.5. 1 times D is just D. We take 50 and we multiply it by 3.5. And we get 175. This is going to be miles. Okay, one thing we want to make sure we do when we're always doing scale is that we put the map distance over the actual distance. So we always want to put the map over the actual. Okay, and that'll just keep it consistent for any problem that we do. So the distance on the map over the actual distance in real life. All right. Number 2, a liquid outer core of Earth is 2,300 kilometers thick. A scale model of the layers of the Earth has a scale of 1 inch to 500 kilometers. How thick is the liquid outer core of the model? So I want you to try to set up that proportion. If you need time to write it down, please pause the video before I start writing so you can think for yourself. All right, this left side should be the fraction for the information we were given, which would be 1 inch over 500 kilometers. Now it does not matter which one's on top or bottom as long as inches is on top if inches is on top over here, or kilometers is on top if kilometers is on top over there. The other piece of information we were given was 2,300 kilometers. That is going to go on the bottom of our second fraction since kilometers is on the bottom of my first fraction. And I want to know how thick that outer core of the model is, so my x is going to be x inches. All right, so now to solve, if again, please pause the video so you can try to solve this on your own and then you can resume the video to check it. We're going to just be multiplying those cross products. So I take 1 times 2,300, which just gives me 2,300, which is equal to my other cross product, 500x. Next step, I'm going to divide by, oops, sorry, not yet, I'm just going to rewrite this. Next step, I'm going to divide by 500 to get that x by itself. And I will get x is equal to 2,300 divided by 500, 4.6. Look up to see where that x is, what label that is. It's going to be inches. All right. Pretty simple stuff. As long as you know how to set up the proportion, the rest is pretty simple. When we are solving these problems, you will have to solve them with a proportion. So do not try to do any mental tricks. You could do mental tricks to check your answer, but like your work on your test that you're going to take has to be proportions. So you might as well get in the habit of it. Number 3, I want you to try this on your own. So I would, oh no, we haven't done one like this, sorry. The scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. So the scale of the model is 10 inches is 100 feet. Okay, so 10 inches is 100 feet. They want to know what is the scale factor. So the scale, that is our scale. Okay, we don't have to simplify scale, that's what they gave us. The scale factor, we do have to simplify that fraction. So I could divide the top and bottom both by 10, which would give me 1/10. So the scale factor of the model is 1/10 the size of what the actual monument would be. All right, and here's where we see that difference between scale and scale factor. Scale factor is talking about how much of the size the scale or model is, and the scale factor is just talking about the difference in those measurements. Okay. Last one, Central Park is a rectangular park in New York City. Okay, for A, we want to find the perimeter and area of Central Park in the scale drawing. Okay, so the first thing we have to do is measure this out with a centimeter ruler. Measure this out with a centimeter ruler. So if I measure this out, I'm getting 12 centimeters. When I measure this out, I'm getting 2.5 centimeters. So letter A is just asking for the area and perimeter of that scale drawing. So for A, we're going to do the area, which is just length times width. So we're going to take 12 times 2.5. And 12 times 2.5 would give us 30. And that is centimeters squared. Okay, the perimeter, we have to add all the other sides. So this would also be 12. This would also be 2.5 is going to be 12 plus 12 plus 2.5 plus 2.5. Here I get 24. I should get 29 centimeters. And since it's perimeter, it's just centimeters. We're not multiplying anything, so it's not centimeters squared. All right, so that was a simple part. Now we have to find the actual perimeter and area of Central Park. Okay, given those scale models. To do this, we are going to use proportions, and the way that we need to use proportions is to find the actual length and the actual width, because once we're given those actual lengths and actual widths, we can find the area and perimeter. Okay, so first let's find the actual length. So the scale they give us is 1 centimeter is 320 meters. So we're going to set up that proportion. 1 centimeter is 320 meters. We know that the scale is 12 centimeters. We want to know how many meters that is. Okay, so once you have that copied down, please pause the video, solve it, and then resume the video to check your answer. We have cross products here. 1 times x is just x. 320 times 12. We do need to be showing this work. We get 3,840 meters. That's our length. All right, now I would like you to pause the video since we went through that first one together to write a proportion and determine what the actual width of the park is in real life, still using that same scale factor. All right, so pause it and then resume to check your answer. Still have that same first fraction. Now we have 2.5 centimeters, and we want to know how many meters that is. We use those cross products. 1 times x is just x. And we now take 320 times 2.5. And we get x is equal to 800 meters. Okay. Now to find that area, we have to do length times width. Okay, so we have to take 3,840 times 800. We get 3,072,000 meters squared. That's insane. That's huge. All right. Then for perimeter, we add our length plus width plus width. So we have 3840 plus 3840 plus 800 plus 800. And when we add those up, we will get 9,280 meters. Remember, perimeter is just meters because we're not doing any multiplying, so it's not meters times meters. Okay, now let's do something, because I know that many of you are saying, well, Miss Lakin, if we found the area of the scale and the perimeter of the scale, can't we just multiply by 320 to get that answer? And we're going to check to see if that works. Okay, so let's first start with that area. We have 30, and let's take in our calculators 30 times 320. We get 9,600. Is that the same area? No. Because we are needing to multiply our length by 320 and our width by 320. So when we take our area and only multiply it by 320, we're missing out on that other dimension. So that would be taking 12 times 320, but then still multiplying it by 2.5, which would not get us the area of that actual park. We'd have to take this times 320, this times 320, and then multiply them. Okay, so when we took 30 times 320, we got 9,600. Now if we multiply that by 320 again, that's when we get this answer. Okay, so make sure we're not shortcutting that area. Perimeter, however, since we're not multiplying, we're just adding distances, it might work. So let's take 29 times 320, and we get 9,280. So since we're not multiplying and we're just adding, when we multiply by 320, that distributes to all these numbers, so we would get the same number. All right, I just wanted to point out the difference there, because I know some of us would want to take that shortcut of just multiplying these numbers by 320, and we're not going to end up getting the same answer, at least for the area. Okay. And that is it for our lesson today, just using proportions to set those up, noticing the difference between scale with those two measurements, and scale factor talking about the size difference. But other than that, just setting up those proportions with the given one, making sure that our map or scale size is always on the top over the actual size. Okay. And that is our lesson on scales.